Okay, so now we are come to last part for week 8. Okay, so we have discussed these two learning outcomes, and for this part, so at the end of this part, you should be able to evaluate definite integrals using the fundamental theorem of integral. So for LO1 and LO2, so we have discussed the indefinite integral. Okay, so where if you have indefinite integral, so your solution for the integration, you need to put plus c, which is plus constant. Okay, but for definite integral, so no need to put plus c, but you need to replace the x. You need to, you can have a value for that. Okay, so in this section, we will discuss the integrals with the limits of integration. So the difference for definite integral is this one. Okay, so you have the limits from a to b. Okay, so a and b are constants. Okay, and the constant a is known as the lower limit of integration, while b is known as the upper limit of integration. So this type of integration is called the definite integral. Okay, so let's move to theorem number 3, which is the fundamental theorem of calculus. So if a function f(x) is continuous on the interval ab, then integration of f(x) dx from a to b, we can write as capital Fb minus Fa. So this capital is actually the function that you have integrate. Okay, so integrate f, you will get a function. So, and that function will be in terms of x. So that x, you substitute with the b, okay, the upper limit first, and then minus the substitution of the lower limits, right? Next is theorem 4. So basic properties of definite integrals. So if f and g are continuous function on the interval ab, then we have fx from a to a is equal to 0. Okay, because we have the same value, fa minus fa. So you will get 0. Okay, and if you have integration of fx where the limit is from a to b, is actually you will get the answer is the same if you put the limits from b to a, but you will have negative in front. Okay, if you have negative answer for limits from a to b, then you will get positive answer if you have the limits from b to a. Okay, so third, okay, the third properties is constant. So same as before, you can bring the constant in front. Okay, and if you have a constant function, okay, differentiate constant function where you have the limits, so the answer will be kb minus a. Okay, and this one, if you have fx, integration of fx from a to b, so actually you can split the function into two parts. Okay, so this type of properties, so maybe we will discuss later during the application of integration. Okay, and one more thing is if you have two functions fx and gx, so if you have f plus g, so you can split f and g into two different integration, but with the same limits of integration. Okay, so let's look at example 6. Okay, evaluate the following integrals. So now we have the function 3x squared plus 7. So what you need to do is you just integrate as usual. Okay, so integrate, you will have 3x cubed over 3 plus 7x. Okay, and if you don't have the lower and upper limit, so you need to put plus c. But since this is definite integral, so we don't have the plus c there, but you need to put the lower and upper limits. Okay, so now this one can be cancelled out. So you have x cubed plus 7x, where we will substitute x equal to 2 and 0. Okay, so substitute with 2 first. So we have 2 cubed plus 7 times 2. Okay, and then minus 0 minus 0. So you get what? 8 plus 14, which is equal to 22. Okay, so this is the answer for the definite integral. Okay, so let's move to question B. Okay, again, this is the definite integral. So integrate as usual. Okay, but before integrate, since we have the square root there, so we just change it to powers. Okay, x to the power of half plus x to the power of negative half. Okay, so this one, differentiate, you will get, integrate, you get over 2, and this one is 3 over 2. Okay, plus x to the power of negative half plus 1, so you get 1 over 2 and then over 1 over 2. Okay, so the limits is from 1 to 4. Okay, restructure, so you get 2 over 3x to the power of 3 over 2 plus 2x to the power of half. Okay, substitute x with 4. And minus, substitute x with 1. Be careful with the minus here. Okay, so now you can solve this. You can use your calculator or you can just solve it manually. Okay, and you will get, the answer will be 20 over 3. So it's approximate to 6.667 something. Okay, alright. So for definite integral, you will get value. Okay, you don't have any function because you have substitute all the functions with the lower and upper limits. Right? Okay, let's move to question C. Okay, we have this type of questions. We have a fraction here. So this one you cannot use the quotient rule because this is not the differentiation. So this is integration. So simplify first. Okay, so to simplify this, we can have 2x cubed minus x cubed. So you have, I just write this one. I split this first. Okay, so here I will have 2 plus x to the power of negative 3 dx. Okay, so this one has not been solved the integration. We just simplify first. Now we solve for the integration. We integrate the function. Okay, 2 plus x to the power of negative 3. So we have 2x plus x to the power of negative 2 over negative 2. Okay, so substitute the upper limit, which is 2. So here actually we can have as 1 over 2 times 2 squared. Okay, because this term I write as negative 1 over 2x squared, right? Okay, and then we put minus, and I put in bracket, substitute x with 1. Okay, so be careful with this negative, so put everything is in bracket. Okay, so solve all these numbers. Okay, and you will get 9 over 8, sorry, 19 over 8 is approximate to 2.375. Okay, so this is the answer for question C. Right. Okay, so we comes to the last example. Okay, we have a product. Okay, we have a product of x plus 2 and x plus 3. So this one you cannot use product rule because this is not the differentiation but integration. So for this question, what you need to do is you expand the factorization. Okay, you expand the product, so expand it, you will get what? X squared plus 5x plus 6. Okay, so now we have the function. Okay, no need to modify the function, we just integrate it. So we have x cubed over 3 plus 5x squared over 2 plus 6x, and the limit is from 1 to 2. Okay, so we substitute the upper limit first, which is 2 cubed over 3 plus 5 over 2 squared plus 6 times 2. Okay, and then minus 1 over 3 plus 5 over 2 plus 6. Okay, right, so you can solve all the numbers here. Okay, substitute the upper and lower limits, and you will get the final answer is 95 over 6. You can try this. Okay, alright, so that's all for this part. Okay, so we have done for week 8, so we will continue later for content in week 9. Okay, thank you.